First of all, I welcome all the students and the participants who are attending this live lecture, especially who are arrived in my friends, that is Rutika Tatewar, Pooja Andure, Madhuri Pawar, Ganesh Kale, Suraj Shalunke, Sanke Sulat, Ravina Patil, Rutuja Bhosle, Adnya Wadwole, Sarika Parale. देखो अभी we shall discuss this in this lecture. This is the special type of a differential equation, and that special type of a differential equation, then that equation is called as a Bessel's equation. Actually, this is the research paper of a scientist Bessel's. He made a solution of some particular type of a differential equation, and it has a second order differential equation which is analytic at some particular point, and he gave the solution of second order linear differential equation which is a homogeneous form, and he gave a solution in the form of a series, and that solution is called as a Bessel's function. See, this solution of some particular type of a differential equation given by a scientist Bessel. So that solution is called as a Bessel's function, and the differential equation which he has solved, he had been solved, and that differential equation is called as a Bessel's differential equation. See this. Actually, यहाँ पे जो हम यहाँ स्टडी करने जा रहे हैं बेसल्स डिफरेंशियल इक्वेशन, दिस इज द पर्टिकुलर टाइप ऑफ डिफरेंशियल इक्वेशन विच इज यूज्ड इन द फिजिक्स, but he solved this differential equation by the process of a mathematics, and he find out a particular solution. उसने पर्टिकुलर सोल्यूशन फाइंड आउट किया बेसल्स ने, और उस पर्टिकुलर सोल्यूशन को उन्होंने बेसल्स फंक्शन नाम दिया है. सो यू नो दैट इट इज द फेमस फंक्शन. बेसल्स फंक्शन इज अ फेमस फंक्शन. Actually, it is the solution of some particular type of a differential equation which we have to study today. See this. Actually, we shall discuss the Bessel's differential equation or Bessel's equation. Now, first of all, we shall define what is mean by the Bessel's equation. सबसे पहले हमें क्या करना है, Bessel's equation डिफाइन करना है. बाद में उसके लिए कुछ एक इम्पॉर्टेंट नोट लगने वाली है वो देखेंगे, और बाद में प्रूफ की तरफ जाएंगे. ओके, नाउ सी दिस. let suppose alpha be a constant. Let alpha be a constant. Alpha be a constant such that a real part of alpha which is greater than or equals to 0, this is the most important condition, then the differential equation of the form that is x square y double dash plus x into y dash plus x square minus alpha square into y, which is equals to 0, is called Bessel's equation. Bessel equation. Bessel equation of order. Actually, differential equation is of order 2, second order differential equation, but this is a Bessel's equation and he defined the order of this differential equation, which is depend on the alpha. So Bessel's differential equation of order alpha, see this. Now we can write this equation of the form, we can write this equation. Alpha means this is not a differential equation order, but he is given this particular equation. It is the differential equation, but it is expressed in terms of alpha. Bessel's equation of order alpha, it is not a differential equation of order alpha. याला काय म्हणतात? Bessel's equation of order alpha. See this. This is the Bessel's equation of order alpha. But differential equation is of order 2. Okay. Now Bessel used the particular symbol here, alpha. Students, Snehadon, Indrayani, Swati, Supriya, Nandini, Pragati, Vinod, Bellale. Now you tell me, what is the difference between Bessel's equation and Euler's equation? अभी सभी ने बताना है. In the last lecture we have seen Euler equation. बराबर है ना? Now you tell me what is the difference between the Euler equation. Already we have seen second order differential equation, that is Euler equation. What is the difference between Euler equation? Now you tell me. Now here see this, we shall discuss this differential equation has the form equation has the general form has the form, we can write this as x square y double dash plus a of x into x y double dash plus b of x y, which is equals to 0. This can be generally represented in this way. You can take this. So where a of x is equals to 1 in this case, and b of x is equals to, what is the value of b of x? Students, आन्सर नाही देत मी. काय विचारलं तुम्हाला? ऑयलर इक्वेशन आणि बेसल्स इक्वेशन मध्ये काय फरक आहे? एग्जाम मध्ये क्वेश्चन सुद्धा असा विचारतात, विच ऑफ द फॉलोइंग इज बेसल्स इक्वेशन, which of the following is Euler equation. Now you tell me what is the difference between Bessel equation and Euler equation. So b of x means x square minus alpha square. See this, where and a comma b are analytic at x is equals to 0. See this. So this is the Bessel's equation. परत एकदा Bessel equation वाचतो. Let alpha be a constant such that real part of alpha is positive or it is equals to 0, means greater than or equals to 0. The differential equation of the form x square plus x square into y double dash plus x into y dash plus x square minus alpha square y, which is equals to 0. This particular type second order differential equation, second order linear homogeneous differential equation is called Bessel equation of order alpha, because the Bessel considers some particular constant alpha. The differential equation has the form, because alpha is Bessel's equation. Bessel equation is totally dependent on alpha. So he considered the Bessel equation of order alpha. This differential equation has the form, we can write in the general form. How we can write here? X square y double dash plus a of x into x y double, sorry यहाँ पे y dash, सॉरी एक मिनिट हां, वी कॅन राईट. लक्षात ठेवत चला रे, इथं चुकलं की सांगत जरा. हां, ये देखो, राइटिंग करते वक्त बहुत बार ऐसा होता है कि मुझे आपकी तरफ देखना होता है, आपको बताने की तरफ देखना होता है, बोर्ड की तरफ देखना होता है, राइटिंग पैड की तरफ देखना होता है. That means we have to manage all these things when we are going to writing something on the board. So we have to discuss towards the board, we have to see towards the board, writing pad towards the screen, towards you. So there are possibility to writing mistakes, simple writing mistakes. So you have to care and you have to tell me somewhere I am going to make a mistake. So this is the concentration of your lecture. Okay, no problem. So this type is the general form of that Bessel's equation, where a of x is equals to 1, b of x is equals to x square minus alpha square, where a and b are the analytic at x is equals to 0. Now some note, which is important note, which we have required for the solution of a Bessel equation, or it is also called as a theorem, statement of some theorem, that is theorem number 4, but it is not in our syllabus. So I have removed this, but we have to write in the form of a notes here. See this, consider the equation, consider the equation, see this, x square into y double dash plus a of x into x y dash plus b of x into y, which is equals to 0, where a and b are power series expansion, power series of expansion, which are convergent for mod x, which is less than r naught, where r naught is the radius of a convergence, so it is greater than 0. Full stop. Let r1 comma r2 be the roots of the indicial polynomial r1 and r2 are the roots of indicial polynomial, that is denoted by q of r is equals to r into r minus 1 plus a of 0 into r plus b of 0. That is, these are the two roots of 0. Then if r1 is equals to r2, if two roots are equal, then we get the solution are equal, and there are two independent solutions. Then the two independent solution, then two independent solution are, see this is the second degree polynomial in R. So it has two roots, it may be equal, it may be complex, it may be real, but it has two roots. So it has two independent solutions, which are given by, that is, phi 1 of x is equals to mod of x raised to r1 into sigma 1 of x, and phi 2 of x is equals to mod of x raised to r1 plus 1 into sigma 1 of x, sorry, sigma 2 of x plus log x into phi 1 of x. Okay, I shall write this second solution below. इथं नाही बसत. And हे नोट व्यवस्थित लिहून घ्या. phi2 of x is equals to mod of x raised to r1 plus 1 into sigma 2 of x plus log of mod x into, so multiplication phi 1 of x. See this, these are the two solutions. If r1 minus r2 is a positive integer, in this way we can write the two solutions whatever may be. If r1 and r2 are the linearly independent, if r1 is not equals to r2, then there is no problem. We have to write the solution, that is a mod of phi 2 of x is equals to mod of x raised to r1, and phi 1 of x is equals to mod of x raised to r1, and second solution is phi 2 of x is equals to r2. We have seen this already. हे आपण अगोदर पाहिलेलं आहे. But if two roots are equal, then we have to write this solution in the form of a sigma, where sigma is the power series or summation series. Sigma is the power series or summation series which is defined by g of x based on the analytic coefficient. So we can write this in this way. Okay. Now we have to use this formula. If ठीक आहे, अशा पद्धतीने हा फॉर्म्युला तुम्हाला लिहिता येईल. पण समजा r1 and r2 are two power series, are linearly independent. r1 is not equals to r2. Okay. So sigma of x is not equals to 0. In this case, sigma 1 of 0 is not equals to 0. इथं लिहून गरज पण नाही आहे. But see this, it is the sufficient. I shall read this again. Consider the equation x square into y double dash plus a of x into x y dash. It is as compared to the Legendre equation, but some difference regarding Legendre equation and this equation, something different. So x square into y double dash plus a of x into x y dash plus b of x into y is equals to 0, where a and b are the power series expansions which are convergent for mod of x is less than r0 or radius of the convergence. If r1 and r2 are the two roots of the polynomial, second degree polynomial, so it has two roots. Suppose r1 is equals to r2, then we can write a first solution phi 1 of x, second solution phi 2 of x in this way. These are the two solutions of this type equation. If r1 is not equals to r2, suppose r1 is not equals to r2, then we can write simply the solution phi 1 and phi 2. So now we have to use the next important theorem, that is a Bessel's equation, that is solution method of the Bessel's equation. How Bessel solve this equation? He get a solution and he get a particular solution. Bessel solved this equation and he got a particular solution in his research paper, and he denoted that solution is Bessel's function also. So we shall discuss the solution method of the Bessel equation. Let alpha be the constant. आता हे तुम्हाला समजून घ्यायचे, फक्त असंच लिहायचे. ठीक आहे. कसं क्वेश्चन कसा विचारला होता? स्टेट द Bessel equation and write the solution procedure of a Bessel equation. Okay, and write the solution procedure of Bessel equation or find out the Bessel's function. So we can write this solution in this way. हे 15 मार्कला विचारतात. खूप मोठा थेरम आहे, 15 मार्कला विचारतात, काही अडचण नाही. See this, if alpha is a constant and real part of alpha is greater than 0, then the Bessel equation of order alpha is the equation of the form x square y double dash plus x y dash plus x square minus alpha square into y, which is equals to 0. आता याच्यावर MCQ बरेचसे क्वेश्चन तयार होतात. MCQ बरेचसे क्वेश्चन तयार होतात. विच ऑफ द फॉलोइंग इज द बेसल इक्वेशन? You can write this. Which of the following is the general form of a Bessel equation? Then we have to write this. In the Bessel equation, the value of A of x is, you have to write this. In the Bessel equation, the value of B of x, which of the following is the value of B of x? Then you have to write this. Means number of questions we can get from this Bessel equation in the form of a MCQ. So you have to careful about each and every step. So you have to careful about each and every step. हे पहिल्या तीनच लाईन मध्ये आपण 4-5 क्वेश्चन तयार करू शकतो MCQ टाइपचे. MCQ टाइपचे तुम्हाला क्वेश्चन सॉल्व करायचे आहेत. तर त्याच्यात तुम्हाला 3-4 प्रकारचे क्वेश्चन तयार होतात. विच ऑफ द फॉलोइंग इज अ बेसेल्स इक्वेशन? A, B, C, D ऑप्शन. Which of the following is the general form of a Bessel equation? Then you have to write. In the Bessel equation, general form of a Bessel equation, A of x is 1, 2, 3, this is a 1, B of x is this. Analytic Bessel equation, the coefficients A and B are analytic at which point? Then we have to write origin, that is x is equals to 0. So number of questions may be arrived from such equations. So you have to write, you have to careful about each and every term. Okay, no problem. Now see this. A of x is equals to 1 because in this case if we compare this with the initial Bessel equation, then we get the coefficient as a 1. And this B of x is compared with the coefficient of y. Y चा coefficient असतो ना. So B of x is given by, how we can write? B of x is equals to x square minus alpha square. Here A and B are analytic at x is equals to 0. You know that the concept of analytic we have seen many times. The Bessel equation has the origin as a singular point. The indicial polynomial q is given by, so we can write the indicial polynomial of that Bessel equation, that is q of r is equals to r into r minus 1. See this. From this and this, we can write r into r minus 1 plus r, and this concept we can write r minus alpha square. So we can write this. This is after solution r square minus r, multiply in the bracket r square minus r plus r minus alpha square. So plus or minus get cancelled, that means r square minus alpha square. This is the polynomial, indicial polynomial of q. So it has 2 roots, alpha square. Now it has 2 roots, alpha r square minus alpha square is equals to 0. So r square is equals to alpha square. So r is equals to plus or minus alpha. So it has 2 solution, r1 is equals to alpha, r2 is equals to minus alpha. Since thus we can obtain the 2 solutions, r1 and r2. It is simple form. Now let us consider alpha is equals to 0. Now suppose, because here the solutions see this 2 roots, solution म्हणण्याच्या ऐवजी आपण म्हणू roots. Here the 2 roots of a polynomial, second degree polynomial q of r are, first root is r1 is equals to alpha, second root is r2 is equals to minus alpha, means roots are depend on alpha. Now see here, roots are depend on alpha. Now suppose that alpha is equals to 0. First, since the both roots will be equal to the 0, alpha is equals to 0 means r1 0, r2 is also minus alpha means it is also 0, then both roots are equal. In this case it follows the theorem 4. Theorem means we have considered this as a note. We have given this note according to this note. Say this. according to this note. Okay, this is also one theorem, but we have to write theorem number 4. There are two roots. There are two solutions, phi 1 and phi 2, such that phi 1 of x is equals to sigma 1 of x, phi 2 of x is equals to x into sigma 2. See this, x into sigma 2 plus log of x, phi 1 of x. See this, this is the solution, because we have given two solutions, R1 and R2 are 0. Actually, according to the theorem, phi 1 of x is equals to, what is the solution? Actually, we have seen that mod of x raised to R1 into sigma 1x. According to the theorem or according to the note. आता आपण जी नोट पाहिली त्याच्यामध्ये असं सोल्युशन होतं. R1 ची व्हॅल्यू 0 आहे. So R1 is equals to 0. So this goes to 0. 0 into 1 means this is 1. 1 into sigma 1. So we get this solution. अशा पद्धतीने सोल्युशन होतं. आणि इथं पहा phi 2 of x is equals to again same. Again same, we can write this. कसं लिहिता येईल पहा? Phi 2 of x is equals to, we can write according to the note, mod of x raised to R1 plus 1, okay, into sigma 2 of x plus log of x into phi 1 of x. According to the theorem 4 or according to the note which you have given here. So if we put R1 is equals to 0, R1 ची value 0 plus 1 means 1. So we get this as 1 means x. इथे x येतो. X into sigma 2, this is as it is. So we get, according to the note 4, we can write phi 1 of x is equals to this, phi 2 of x is equals to this, where sigma 1 and sigma 2 are the power series expansion which are converges for all finite x. Now let us calculate the value of sigma 1 and sigma 2 for the moment. So we have to replace the value of sigma 1 and sigma 2 to find the solution. So L of y is equals to x square y double dash plus x into y dash plus x square y. See here, we have to find out the value of sigma, and we have consider alpha is equals to 0 here. Actually the Bessel equation is x square minus alpha square into y. If we put alpha is equals to 0, then we get this equation. We have considered the case. First we have considered this case, alpha is equals to 0. Now according to the consideration of alpha is equals to 0, we have to find out the values of sigma 1 and sigma 2. हे खूप मोठा पेपर आहे, रिसर्च पेपर आहे. हा रिसर्चचा पार्ट आहे. हे मॅथमॅटिक्स मधला सिंपल पार्ट नाही आहे. दिस इज द थेरम. This is the theorem which is given by Bessel in his proof, in his research work, and we are going to see this here. Okay, actually हा रिसर्च पेपर आहे बेसलचा. बेसलनी रिसर्च केलेला रिसर्च पेपर आहे आणि बेसल फंक्शन फॉर्म केलं. बेसल फंक्शन हे खूप चाललं. बेसल फंक्शनचं खूप ॲप्लिकेशन आलं. या टाईपचे सर्व इक्वेशन सॉल्व करण्यासाठी बेसल फंक्शनचाच वापर करतात. आणखी असे जर इक्वेशन आले, डिफरन्शियल इक्वेशन असतील, तर आणखी बेसल फंक्शनचा वापर करून कम्प्युटरच्या सहाय्याने त्याचं सोल्युशन काढतात, त्याचे ग्राफ्स काढतात. लक्षात घ्या. म्हणून ते बेसल फंक्शन खूप फेमस झाला. या बेसल डिफरन्शियल इक्वेशनपेक्षा बेसल्स फंक्शन हा खूप फेमस झाला, की जे आपण पुढे पाहणार आहोत. नाउ सी दिस, अकॉर्डिंग टू द ॲनालिटिक कोएफिशियंट वी कॅन एक्सपांड. हे झालेलं आहे आपल्याला. ॲनालिटिक कोएफिशियंटमध्ये एक्सपान्शन कसं घ्यायचं काय नाही, सिंगल पॉईंट. तर सिग्मा 1 ऑफ एक्स इज इक्वल्स टू, वी कॅन राईट के इज इक्वल्स टू 0 to infinity ck into x raised to k. वी आर ऑलरेडी सीन दिस. ओके, आता मी थोडं फास्ट घेतो कारण हे पार्ट तुम्हाला ऑलरेडी झालेलाच आहे. So sigma that now if we differentiate this sigma 1 of x, then we get power multiple मध्ये घ्या, power 1 न कमी. So k into ck, constant coefficient is as it is, x raised to k minus 1. If we again differentiate this, then sigma 1 double dash is equals to k is equals to 2 to infinity. See this, again k, power multiple मध्ये घ्या, k minus 1 into ck into x raised to k minus 2. Here k is equals to 2. अगर k इज इक्वल्स टू 0 नाही येणार, आता सेकंड डेरिव्हेटिव्ह घेतलं तेव्हा 2, थर्ड डेरिव्हेटिव्ह घेतला तर k इज इक्वल्स टू 3, नाहीतर 1 पासून घेतला तर हा 0 होतो. इथं जर 0 पासून घेतलात, समजा इथं जर 0 घेतलात, then it will be goes to all terms will be 0. So you have to differentiate this phi 1 dash means we have to take k is equals to 1. For phi 2 dash, for second order derivative, that means sigma 1 double dash, you have to take k is equals to 2. Sigma 1 dash, k is equals to 1. For sigma 1, then k is equals to 0. You note that. Now multiplying by x square, because the coefficient of y double dash is x square. We have considered sigma 1 of x is the first solution. Sigma 1 म्हणजे first solution आहे असं consider केलं. So x square is equals to 5 sigma 1 double dash of x means we can write, याला जर x square न multiply करा, after multiplication of x square, multiplying x square केलं तर k raised to x raised to k minus 2 into x square means we can write this as x raised to k. Remaining terms are as it is. Also you have to find the multiplying by this with x, and you have to write k is equals to 1 to infinity separate. That is, याला जर multiply केला तर x raised to k minus 1 into x raised to k minus 1 into x means x raised to k. Now we have to distribute this. आता याला दोन पार्ट मध्ये करा. Now distribute this summation. If we put directly k is equals to 1, then we get the first term c1 of x. See this, k is equals to 1 means this one, c1 x raised to 1, so it gives c1 of x, and from k is equals to 2 to infinity, put this value as it is, because we have to take the common in between two terms. So we have to use summation k is equals to 2 to infinity, k is equals to 2 to infinity in double dash. आता k is equals to आपल्याला कॉमन काढायचे, पहा k is equals to 2 समेशन हे कॉमन काढायचे, इथनं आणि इथनं ॲडिशन करायचे. त्यामुळं मी काय केलं लक्षात आलं का, इथं सेपरेट केलं. सो ऑल्सो x square into sigma 1, you know that sigma 1 k is equals to 0 to infinity ck x raised to k plus 2, x square न multiply केला sigma 1 ला, because you know that the coefficient of, here the coefficient of y is x square. Suppose this is a sigma 1, so we have to multiply by x square, multiply by x square to sigma 1, then we get the third term. तिसरी टर्म मिळते, फर्स्ट टर्म, सेकंड टर्म, थर्ड टर्म. दिस इज अ फर्स्ट टर्म, this is the second term, this is the third term in the form of a sigma. So we can write this as, so we have multiplied here in this case, 1 minute. So we have to multiply by this, then we get x square into sigma means this, and we can write k is equals to 0. If k is equals to 1, k is equals to 0 ठेवला, k is equals to 1 ठेवला, तर या टर्म अशा येत जातात. So we can write in this way, we can expand this, k is equals to ck minus 2. आता k is equals to 2 ठेवा, म्हणजे हीच टर्म. We have changed this summation from k is equals to 2. हे जे समेशन आहे, हे समेशन k इज इक्वल्स टू 0 होता, त्याला आपण k इज इक्वल्स टू 2 मध्ये कन्वर्ट केला बाय डिक्रीजिंग टू टर्म्स. इथं ck होता, we have written here ck minus 2, and x raised to k plus 2 होता, we have written x raised to k. That means the value of both summations are same. This and this summation both having a equal value. पण हे आपण का कन्वर्ट केलं k is equals to 2 to infinity, because we have to add this term plus this term plus this term. We have to add these three terms. So for a common, taking a common purpose, we have written in this way. Okay, no problem. चला थोडं फास्ट घेऊ आपण. So we can write by adding here. इथं लिहितो मी वाटलं तर by adding see this by adding three terms. Okay, so we get याला sigma 1 of x is equals to c1 of x plus आता ॲडिशन करा 1 2 3 चं ॲडिशन करा म्हणजे ही टर्म येते पहा. see this by adding okay याची ॲडिशन करा. we have to add 1 2 3. so you can take summation common, summation k is equals to 2 to infinity. we can take a common summation from this you can take the common. Summation is the common. This term, first term is it is c1 into x. Summation is common. Again we can take the common. काय common घेता येईल? x raised to k, x raised to k, x raised to k. We can take common. Again, so the remaining terms are k into k plus 1. परत ck इथं common काढता येईल. इथं term plus ck या पहिल्या दोन मधून ck minus 2. So we get the relation this. इथं ठीक आहे. So we get the relation this. Now we know that c1 is equals to 0. If c1 is equals to 0, then this goes to the 0. Then the term becomes, we can write this as the equation in this way. आता यामध्ये जो x raised to k common होता, we can take in the division, then we get the coefficient k into, समजा c1 is equals to 0. आता इथं पहा, परत एकदा सांगतो मी, the addition of these two terms which is equals to 0, that means first term must be 0 or second term must be 0. In that second term, we can divide this. Yesterday in the last lecture already we have seen this. So we can write this. Okay. The second set of equation is the same as ck is equals to, we can write this. याला कसं लिहिता येईल पहा? ck is equals to, now this is a k square minus k plus k into ck plus ck minus 2 which is equals to 0. Plus k minus k will be get cancelled. Then we can write ck is equals to minus ck minus 2 divided by here k square. So we get this result, ck is equals to. You can see this is the simple mathematics steps. या सर्व mathematics step आहेत आता simple. So k is equals to from 2 to 2, 3, 4 up to infinity, because there is a summation and we can write this as 2 to 4. So now the choice C0 is equals to 1 implies C2 is equals to. आता समजा we can put, if we put 2 in this equation, then k means 2, 2 minus 2 means 0, then C0 suppose 1, that will be 0, 0 means suppose 1, divided by k is equals to 2 means minus 1 by 2 square, then C2 is equals to 1 by 2 square. If we put 3, if we put 4, आता याच्यानंतर 4 ठेवला तर 4 ठेवल्यानंतर काय होतं पहा, if we put 4, then C4 divide by, फक्त इव्हन टर्म ठेवा अगोदर. if we put 2 then 4 then 6, then we get C2 divided by minus C2 divided by 4 square. For k is equals to 1, 2, 4, 6, 8, then we can write this. In general, we can write C2m. In general, C2m means for even terms, minus 1 raised to m, 2 raised to 2, 2 raised to 4, dot in this way, 2m raised to 2. So it can be written as minus 1 raised to m divided by 2 raised to 2m into m factorial. यालाच असं लिहिता येतं, m factorial its square, m is equals to 1, 2, 3. These are the constant, odd term constant, sorry, even term constant. Now we can also calculate the odd term constant. If c1 is equals to 0, if c1 is equals to 1, then we get the even term constant. If C1 is equals to 0, then we get the odd term constant, that is C3, C5, C7, which are 0. इथं ठेवा, C1 ची किंमत तुम्ही 0 ठेवली. See this. If we put C1 is equals to 0. Okay, now if we put 3, आता पहा, K is equals to 3, means C, 3 minus 2 means 1, divide by K means 3, 3 square. But C1 is 0, we have considered 0, 0 divided by 3 square means 0. If we put K is equals to C3 is equals to 0, thus we get C3 is equals to 0. Means for odd term, C3, C5, C7 dot dot will be 0. Thus the sigma 1 contains only even powers of x, and we get sigma 1 of x is equals to, from this, sigma 1 of x is equals to summation m is equals to 1 to infinity minus 1 raised to m into x raised to 2m, because it has only 2 power. यात ठेवा sigma 1 of x. इथं ठेवलं, x raised to k न मल्टिप्लाय केला आणि C1 च्या व्हॅल्यू, replace this ck. See this? To obtain the sigma 1, replace this ck in the series form, in the factorial form, in the form of m. So we get the sigma 1 in the form. So this is the sigma 1. हे खूप म्हणजे इंटरेस्टिंग आहे, खूप मोठा थेरम आहे, पण इंटरेस्टिंग थेरम आहे. पहा, this is the sigma 1. So we can write this. Now where 0 factorial means 1 and 2 raised to 0 means 1, the function defined by this series is called Bessel's function of 0 order of the first kind. This is called as a Bessel's function of first kind. This is the Bessel's function. This is this, both are the same, but this is the value of sigma 1 corresponding to the differential equation. बेसलनी काय केलं, जी आलेली सिग्मा 1 व्हॅल्यू होती ती एक पर्टिक्युलर फंक्शन होता, तो एक वेगळ्या पद्धतीचा फंक्शन मिळाला होता, विच गिव्स द सोल्युशन. हा सोल्युशन देतो त्या डिफरन्शियल इक्वेशनचं. मग हा पर्टिक्युलर फंक्शनला त्यांनी काय केलं, बेसल फंक्शन म्हणून नाव दिलं. आणि बेसल फंक्शन means J0 or J0 of x is equals to summation m is equals to 0 to infinity minus 1 raised to m divide by m factorial its square divide, इथं कॉमन काढला हा, 2 raised to m, x raised to 2m divided by 2 raised to 2m. If we take this common, then we can write x divided by 2 bracket raised to 2m. So this function is called as a Bessel's function of 0 order. of 0 order का रे स्टुडंट सांगा बरं, आता कोण सांगतं? Bessel's function of 0 order. Why he told this 0 order? Why is it written in the form of 0 order? Because this Bessel's function gives a value j of x when alpha is equals to 0. This is the answer. This is the particular type of a function. This is the Bessel function when he consider alpha is equals to 0. So this is called as a Bessel function of order 0, means first kind. Bessel function of order 0, or it is also called as a Bessel's function of first kind. लक्षात ठेवा. अरे आन्सर देणारे मुलं मला पाहू द्या, कोण ऑनलाईन आहेत कोण नाही. हां बरोबर आहे, सारिका बोळेगावचं खूप कॉन्सन्ट्रेशन आहे. पहा, अल्फा ऑर्डर 0, अल्फाची व्हॅल्यू 0 असताना बेसलचं हे फंक्शन होतं. हे खूप, हे पहा तुम्हाला मी सांगतो, बेसलच्या इक्वेशनपेक्षा, बेसलचं डिफरन्शियल इक्वेशनपेक्षा जास्त फेमस जर काय झालं तर त्याचं हे फंक्शन फेमस झालं. बेसलचं फंक्शन खूप फेमस झालं. खूप ठिकाणी प्रॉब्लेम, फिजिक्सचे प्रॉब्लेम सॉल्व्ह करण्यासाठी बेसलचं फंक्शन वापरतात. पण याला फर्स्ट काइंड म्हणतात का म्हणतात, किंवा ऑर्डर 0 का म्हणतात? Because he obtained this function, he obtained this solution under the consideration of alpha is equals to 0. Under the consideration of alpha is equals to 0. Okay, no problem. See here. Now see here. Now we can find the second solution, that is phi 2 of x. Now see this. phi1 and phi2 are the solutions of differential equation. Now we can write this. हे खूप महत्त्वाचं आहे. इथपर्यंत लिहिला तरी मग सफिशियंट आहे. We can write this. थेरम इथपर्यंत लिहिला तरी चालतो. आता सेकंड फॉर्म आपण घेऊ, सेकंड सोल्युशन किंवा सेकंड काइंड आपल्याला माहीत पाहिजे तुम्हाला पण, म्हणून मी समजून सांगतो. गरज नाही, ऐका रे, पुढच्या पार्टची गरज नाही आहे, परंतु तुम्हाला हे समजून सांगतो. इथपर्यंत लिहिला तरी चालतं. दिस इज द वन टाइप ऑफ अ सोल्युशन. हे सुद्धा बेसल इक्वेशनचं सोल्युशन आहे. ठीक आहे. नाव phi2 ऑफ x इज इक्वल्स टू, दिस इज अ phi2. phi2 dash of x is equals to summation, if we differentiate this, phi2 dash is given by equation first, we have written there phi1 and phi2, तिथं या किमती ठेवल्या. So phi2 double dash means if we differentiate this, differentiating with respect to x, then we get a phi2 double dash. So we can write the L of phi2 of x means second solution form. So x square into phi2 double dash of x plus x into phi2 dash of x plus x square into phi2 of x. Then we get, putting these values by adding these, सर्वांचे addition करा, then we get this relation. So but we know that phi1 of x is the solution of differential equation 1. So we can write L of phi1 of x is equals to 0. That means left side 0. That means right side goes to 0. Right side सुद्धा काय होते, 0 होते. So we can write this sides. So this goes to 0. phi1 of x goes to 0. Means this goes to 0. So the remaining terms are in this way. Okay. So एक minute. So this can be written as, here c1 is equals to 0. c1 is equals to 0. Then 2 raised to 2, c2 is equals to 1. You can see this is equals to 0. And we see that since the series in the right has only even powers of x, see this, in the series we can see that the right side of this series even powers of x, x raised to 2m means it is the even powers, these are the even powers. So we can write this as even powers of x. So now recurring the relation of these coefficients, by using this relation we can write this relation 2m raised 2m bracket square into c2m plus c2m minus 2, which gives the relation this, that is m is equals to 2, 3, 4. From this above relation we can write. So c2 is equals to 1 upon 2 raised to 2, c4 is equals to 1 upon 4 raised to 2, in a bracket we can write minus 1 upon 2 raised to into minus 1 upon 2 into 2 raised to. So this can be written as c4 is equals to minus 1 upon 2 raised to 2 into 2 raised to 4, 1 plus 1 by 2. हे नंतर पहा तुम्ही डीप मध्ये. तसंच c6 we can write 2 raised to 1 upon 2 raised to 2, 2 raised to 4, 2 raised to 6, 1 plus 1 by 2, 1 by. This is the series expansion form. So, and can be shown by the induction that c2m is equals to c2m is equals to minus 1 raised to m minus 1 divided by 2 raised to m minus 1 into m factorial bracket square 1 plus 1 by 2 plus dot 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 1 by m, where m is equals to 1, 2, 3. So this solution, the solution determined, is called Bessel's function of order 0 in second kind. In second kind, and it is denoted by k naught of 0 here. So k naught of 0 is equals to minus summation m is equals to 1 to infinity minus 1 raised to m divided by m factorial its square, this 2 raised to m and x raised to 2m ह्याच्यामध्ये ठेवला तो सुरुवातीला. So we can written this x divided by 2 raised to 2m plus log of j0, and remaining terms are 1 plus 2, 1 by 2 in this way. So this is called as a Bessel's function in second kind. Bessel's function in second kind means under the consideration of second solution, that is phi2 of x. The Bessel's both are condition 0 order, दोन्ही condition पहा, both are in 0 order, and Bessel's function here both are under 0 order, that is alpha is equals to 0, but this is a from phi 2 of x and j of k naught of x means it is obtained from phi 2 of x and j naught of x which is obtained from phi 1 of x. Both are the Bessel's function. Exam मध्ये विचारतात which of the following is the MCQ type मध्ये which of the following is the Bessel's function of order 0 in second kind, means you have to write this. Which of the following is a Bessel's function, see this, which of the following is a Bessel's function of order 0 in first kind, then you have to write this. Okay, अशा पद्धतीने हा Bessel's function होतो. इथपर्यंत सॉल्व केला तरी चालतं, काही अडचण नाहीये. पुढचा पार्ट हा सेकंड टाइप कॅल्क्युलेट करण्यासाठी होतो. हे पूर्ण 15 मार्काला विचारलं जातं. स्टेट द Bessel equation and find its solution method or find the Bessel's functions. तर अशा पद्धतीने याचं सोल्युशन तुम्ही काढू शकता. ओके, तर अशा पद्धतीने हा Bessel इक्वेशन संपतो. 3 आपले महत्त्वाचे म्हणजे 3 युनिट संपलेलं आहे. आता उद्याला आपण 4था युनिट सुरू करू. हे चांगल्या पद्धतीने लिहा. See this students, you write down carefully each and every step with perfect understanding. You write down each and every step of this solution of Bessel equation carefully, each and every step. If you have any doubt in that solution, then you can ask. You come towards me and you can ask. I will explain each and every term. तुम्ही प्रत्येक टर्म चांगल्या पद्धतीने व्यवस्थित लिहून घ्या, सुटसुटीत लिहून घ्या. जिथं स्टेप वाढवता येते तिथं तुम्ही स्टेप वाढवून स्वतःच्या हँडरायटिंगमध्ये चांगल्या पद्धतीने लिहून घ्या. आणखी काय जर तुम्हाला कुठलाही जर काही अडचण आली, यामध्ये काही नाही समजलं, तर येऊन विचारा, मी तुम्हाला समजून सांगतो. ठीक आहे, कारण हे Bessel इक्वेशन खूप महत्त्वाचं आहे आणि हे Bessel इक्वेशनसाठी ही कंडिशन वापरली. phi 1 आणि phi 2 साठी ही कंडिशन. phi 2 म्हणजे सेकंड जो k नॉट ऑफ x Bessel फंक्शन डिराइव्ह झालेला आहे. नोट दॅट द k नॉट ऑफ x इज अ Bessel function of second kind which is obtained from this solution phi 2 of x, and Bessel's function j naught of x which is obtained from the first solution which is in the form of sigma 1 of x. Okay, अशा पद्धतीने हे सोल्युशन होतं. ठीक आहे, तर काही हे खूप मोठं इक्वेशन आहे. ॲक्च्युअली त्याचा बेसलचा हा रिसर्च पेपर आहे. हे काय मॅथमॅटिक्स नाही, त्यानं रिसर्च केलेला रिसर्च पेपर आहे आणि त्यानं फंक्शन फॉर्म केलेत आणि त्या बेसलनी जे फंक्शन्स फॉर्म केले होते त्या फंक्शनला खूप महत्त्व निर्माण झालं आणि बरेचसे फिजिक्सचे प्रॉब्लेम बेसल्स फंक्शनच्या सहाय्याने सॉल्व्ह होतात. म्हणून डिफरन्शियल इक्वेशनपेक्षा बेसल्स फंक्शनला खूप महत्त्व आहे. फिजिक्समध्ये बेसल्स फंक्शनला खूप महत्त्व आहे. मॅथमॅटिक्समध्ये बेसल्सच्या डिफरन्शियल इक्वेशनला महत्त्व आहे. ओके, नाव वी शॅल स्टॉप हिअर. काही अडचण नाही ना स्टुडंट्स? तर काही अडचण आली तर कॉलेजमध्ये या, निवांत विचारा, मी तुम्हाला प्रत्येक घटक समजून सांगतो. ओके, आता ॲक्च्युअली हा एक थेरम आहे पण तो आपल्या सिलेबसमध्ये नाही, पण बेसलसाठी रेफरन्स म्हणून वापरलेला आहे. बेसलचा थेरम प्रूव्ह करण्यासाठी रेफरन्स म्हणून वापरलेला आहे. अनालिटिकचा हा थेरम आहे सेकंड ऑर्डरचा, परंतु हा नोट म्हणून मी तुम्हाला दिलेला आहे माहिती राहावं म्हणून. ओके, नाव वी शॅल स्टॉप हिअर. नमस्कार. आज्ञा वडवळे, सारिका परळे, किशोर क्षीरसागर. ठीक आहे, तर या ठिकाणी थांबू. काय अडचण आली तर भेटा नंतर. हां.